barakatuh. Dear student of third secondary, today we are going to solve chapter 2, chemical analysis. We will start with lesson 1. We have the beginning of the chapter till the end of anions group of diluted hydrochloric acid. Okay, we said that we have in the compound the particle or the part that we called it cation and the other part anion. So we will have the anion groups that carrying the negative charge of the diluted hydrochloric acid. We will start with booklet 13. We have two booklets in lesson 1, booklet 13 and 14. We will solve today booklet 13 from pages 40 to 42 from El Ustaz book. We will start with the first question. Let's go. Question number 1 says that by the addition of diluted HCl acid to different salts, the gas in the following table were released from the tube opening. Study the table, then answer the following. Okay, we have different gases and the molar mass produced from them. We have the molar mass in the unit gram per mole. We have different gases. We have gas A with the molar mass 64 and the other one gas B 44, gas C 34 and gas D 46. Okay, from question starting from question 1 to 5 we have the table here. Okay, at first we will take the atomic masses or atomic weight for the elements that we will discuss or that we will take in the molar mass of them. Okay, at first we will have the molar mass of sulfur 32 and here oxygen 16, carbon 12 and nitrogen 14. So if we calculating the molar mass of each gas, we have the first one, gas A here, we have 64. We have 32 plus 2 times 16, that giving 64. It is the molar mass of what? Which gas? Sulfur dioxide. Another one here, 44. 44 giving the molar mass for the gas B with 12 plus 2 times 16 will giving 44 carbon dioxide gas. The third one here, gas C, with the molar mass 34 and it will be hydrogen sulfide, and we will calculating it 2 times 1 plus 32 giving 34. And the last one with the molar mass 46, we have letter D, nitrogen dioxide, with the molar mass 14 plus 2 times 16 giving 46 gram per mole. Okay, let's continue our question. We have the choices. After that we calculating each molar mass and we knowing each gas from the table, we will discussing the questions from 1 to 5 regarding to this table or these gases that we have. The first question question number 1 says the salt solution of gas what removes the color of the acidified violet potassium permanganate. Okay, here that we take, if we know the effect of acidified potassium permanganate, what is the effect or when we remove the color of it. So we use the gas what? We use one of these gases, sulfur dioxide, carbon dioxide, nitrogen dioxide and the hydrogen sulfide. Okay, at first that we will discuss the question. Here we have confirmatory test or affirmative experiment for this gas. Okay, if we take the nitrite salt solution like NaNO2 that make the reaction with acidified potassium permanganate solution with the violet color KMnO4 in the presence of concentrated sulfuric acid. So the reaction will be here. Explain what happened. Our question will remove the violet color of potassium permanganate. So the effect at the end of it will giving the disappearance of the violet color of what of permanganate due to formation of mixture of colorless solution that giving the nitrite salt NO2 or due to release of NO2 gas. Okay, so we have the equation here. We have our equation NaNO2 aqueous solution plus KMnO4 plus H2SO4 aqueous. All are liquids that giving at the end sodium nitrate NaNO3 aqueous plus potassium sulfate K2SO4 and manganese sulfate MnSO4 plus H2O liquid. Okay, after balancing the equation that we get these products at the end of the reaction. So the salt solution contain what? Contain the nitrite anion. Why? It's oxidizable anion that remove the acidified or make effect on the potassium permanganate and removing its color. Okay, so the salt solution contains oxidable nitrite anion by acidified violet permanganate solution that remove its color violet and become colorless. So the right answer here will be what? Will be the nitrite anion will be letter D. Letter D will be the right answer of question 1. Okay, let's going to question 2 concerning also the table that we have for the elements. Question 2 says that, okay, we have also the atomic masses or atomic weight and we have the molar mass of the gases. Question 2 says that the brown color of iodine solution removed by the effect of solution what? Okay, if we discussing this question, here we have the brown color of iodine. Iodine solution disappears due to formation of which ion that we have? We will have the ion that remove it. So we have what? We have which one gas that will remove the brown color of iodine solution when it present in the solution. Okay, we will discuss it. At first, if we have the iodine solution and its symbol I2 aqueous solution, and we have the thiosulfate salt solution like sodium thiosulfate Na2S2O3. It's a solid, and after adding iodine solution we will get at the end what? We will have sodium tetrathionate and sodium iodide due to formation of sodium tetrathionate and the sodium iodide, which are colorless solution. So the observation that we get from this confirmatory test or affirmative experiment, we have the color of brown iodine solution disappear due to formation of, here we have the equation of it, Na2S2O3 as a solid. We have the sodium thiosulfate salt and we have iodine solution, brown iodine solution. After adding to it, it will remove the color of iodine solution, the brown color of iodine. We have the product here Na2S2 S4O6 aqueous solution, or we call it sodium tetrathionate solution, and at the end we have sodium iodide aqueous solution, which are both colorless solution at the end of the experiment. So we have the solution contain thiosulfate anion due to formation of or the presence of gas what? SO2 gas. Okay, so the brown of iodine solution removed by the effect of solutions that containing letter A, the anion or SO2 gas. Okay, let's going to question 3. Question 3 says that we have no percepted formed by the effect of silver nitrate solution on the salt solution. Okay, if we discuss this question, we have also affirmative experiment that or confirmatory test for this one. We have here bicarbonate salt solution. Okay, we have salt of bicarbonate like NaHCO3, sodium bicarbonate aqueous solution, and we have silver nitrate solution. Okay, AgNO3 aqueous. If we adding silver nitrate to the bicarbonate salt solution, it will giving at the end what? It will giving at the end sodium nitrate and silver bicarbonate aqueous. It will not dissolve in water or make a precipitate. It will no precipitate formed here in our question. So the one that releases that we have here, the one that releases at the end of reaction, the solution contain what? The solution contain bicarbonate anion, HCO3 negative 1, where the silver bicarbonate dissolves in water. Silver bicarbonate here dissolves in water and no precipitate formed. If we have the precipitate formed here, so we have carbonate salt, but we have the aqueous solution here that don't make a precipitate, or we don't have any precipitate, or silver bicarbonate dissolves in water. So we have here bicarbonate solution with negative sign. Okay, so we have our question here, so the right answer will be letter B. Okay, this is question 3. Let's going to question 4 with also the table. Here we have question 4. The smell of spoiled eggs rises by the effect of hydrochloric acid solution on. Okay, we have this question. What will give the, the spoiled egg? The spoiled egg belongs to only one gas. So it will belong to hydrogen sulfide. Okay, I think it's easy question. From the 5, the first one will be easy here. We have question 4, the smell of it belong to the hydrogen sulfide gas. Okay, here we have the basic experiment. We have the solid sulfide salt and group reagent HCl acid, diluted HCl. After we release the smell of what? Smell of hydrogen sulfide. The babe After adding the what? Paper wetted with lead to acetate solution, that we will have the spoiled egg will be released at the end of reaction. So the equation here we have sodium sulfide Na2S solid plus aqueous solution HCl, that will giving sodium chloride NaCl, and at the end we have hydrogen gas evolving with the smell of spoiled egg, and the smell will be or darken the wetted paper with lead to, or become dark in color when paper attached to or becomes nearer to the head of the tube that wetted with lead to acetate solution. Okay, we have here the solution contain the sulfide anion or H2 gas removed at the end of the reaction with sulfide anion is negative 2. Okay, so the right answer here will be letter C. Let's go into question 5 and the last question of this group of questions. We have question 5 here. The clear lime water turned turbid when the salt gas what passed on it for a short time. Okay, I think also it will be easy question. So we have the what which gas will remove the or making the lime water turbid. We have the carbon dioxide gas. So it's easy to know that the clear lime water turn turbid or becomes milky when we have carbon dioxide gas. Okay, we have the right answer here will be, according to the equation, we have hard bicarbonate salt with the group reagent also diluted HCl. We have the effervescence due to carbon dioxide gas. You know that all the soda water that we have effervescence due to removing of carbon dioxide gas. that make the clear lime water turbid when passes for it for a short period of time. And the equation for this basic experiment will be Na2CO3 solid plus HCl aqueous, that giving NaCl aqueous plus CO2 gas evolving with effervescence, and H2O liquid at the end of the reaction. So the gas produced from the salt of bicarbonate anion is carbon dioxide gas that make the lime water turbid. So the right answer here will be letter B. Okay, this is the group of questions belong to the table that we have at the beginning of it. Okay, we will complete our booklet. We have question 6. Question number 6 says that by the addition of solution of silver nitrate to what the precipitate will be formed. We have different choices here. We have sodium carbonate, sodium sulfide, and all of the previous. Okay, if we know that precipitate will be formed in the all of the solution of silver nitrate when added to each one of the following. We have silver nitrate as a strong salt here that will make a precipitate for the weak one that coming from the weak acid, or that salts will be weak than it, as silver nitrate will be the stronger one here that will make the precipitate for sodium carbonate, sodium sulfite, and sodium sulfide. So we have the silver carbonate, silver sulfite, and silver sulfide poorly soluble in water, as they not dissolve in water, as they are weak salts not dissolving in water. So only one here that make them precipitate or make precipitated form all these salts that make the letter D is the right answer for this question. So all the previous making precipitate by adding silver nitrate AgNO3 salt salt solution or aqueous solution for this active what active group. Okay, let's going to question 7. We have question 7 says that by the addition of what? By the addition of potassium carbonate. By the addition of potassium carbonate solution to the solution A that containing the nitrate anion. We have precipitate formed, so the cation of solution A is, we have silver Ag plus, potassium K plus, sodium Na plus, and all of the previous. Okay, if we discussing that we have which one will forming precipitate with the cation solution or with the cation that carry plus 1. We have 3 that carry plus 1, silver, potassium, and sodium. If we adding potassium carbonate solution to this one that containing nitrate anion, we have the potassium and sodium, as they are soluble in water, so they are soluble potassium and sodium, they are active cations that make soluble in water, but silver is a poor as a cation element, cation for the element. We have silver carbonate will be what poorly soluble in water, so we have all carbonate solutions will be not soluble in water, as we discussing before in first secondary that we have table 4 that that anions or that cations that making, or to remember all the cations and anions that soluble or insoluble in water, we have to remember these compounds or these radicals that try to remember them from the studying before. Okay, we have potassium and sodium carbonate soluble in water, but we have silver carbonate not dissolve in water, or we said that it is a poorly soluble in water or slightly soluble in water. So we have the right answer here will be letter A. So we are going to question 8. Question 8 says that which acid decompose to its components easily. Okay, I think also it's a cumulative question here that belong to the first secondary that we have. We have hydrochloric acid, we have carbonic, sulfuric, and phosphoric acid. If we discussing, we will remember that the less stable acid will be volatile and decompose easily in the form of gases. If we said that we have, which one will be, what will be the strong here? Okay, we have the acid that the strong one that not decompose easily, that make the reaction but not decompose easily. We have acid decompose to its component easily as it's weak and volatile and decompose to in the form of gases easily. We have the question, its answer will be here carbonic acid. Carbonic acid will be the less stable acid as it is easy to decompose into its component and it will be volatile in the form of gases. Okay, this is the right answer, but we have very strong acids that we have hydrochloric acid depending on the radical Cl negative, it's strong anion, and sulfuric acid also we have sulfate group SO4, and we have phosphoric acid BO4 negative 3 that we have all these are stronger than the carbonic acid, so it will weak acid that make it ionized easily or decompose to its components easily. Okay, this is one of the accumulative also knowledge that we studied before. Let's go into question 9. Question 9 says that the three groups of the acids A greater than B greater than C arranged in order of stability. So the the more stable one here will be acid A, and the less stable or the least stability will be acid C. We have the sulfurous acid belong to the group of the acids what? We have, if we indicated that the sulfurous acid, it will be what? One of the more stable or intermediate or less stable. Okay, according to it, we have the stronger one that will remove each one. We said that we are discussing the anions of diluted HCl. If we have comparing between the hydrochloric acid HCl and sulfurous acid, it will be less instability. So it will be the least one in the stability, not intermediate. So we have here the three groups of acid belong to the order of stability. We will take the least one. It will be not A or B, or A alone or B alone. It will be the letter C here, the acid that will be less stable, that indicated of the acid expelled by the effect of diluted hydrochloric acid, as it will be stronger than it. So the acid hydrochloric acid will be A or B, but that sulfurous acid in our question will be letter C. Okay, let's go to question 10. Question 10 says that which acid is the stable acid? We want to hear the one stable. Okay, we will make a comparison here. We will make a comparison here. As we said that we have, or we studied before, also it's accumulative knowledge. We have different acids, and the last one is a gas. Hydrogen sulfide, it's what? It's H2S, it's a gas. We have hydrochloric acid here, letter C, HCl. We have nitric acid, HNO3, and the what? Phosphoric acid, H3BO4. As we said that we have, when discussing it, which one their salt don't react with hydrochloric acid. Okay, why? Why? Or it's the stable acid or the most stable one. The most stable acid means that their salt don't react with diluted hydrochloric acid or concentrated sulfuric acid. So it will be, or nitric acid. So it will be what? It will be the stable one or the most stable that not react with nitric or hydrochloric or sulfuric concentrated, as it will be the more stable that carrying three hydrogen anion, so or three protons carrying positive charge here. So the right answer will be letter A. Okay, we must discuss in questions the strong and weak acids in all the accumulative knowledge in studying before. Okay, let's going to question 11. Question 11 says that here we have the same gas evolved from A and B under the influence of diluted hydrochloric acid by bonding the anion B with the calcium cation give the salt that is poorly soluble in water. The two anions respectively are, okay, here we have one that affected by the diluted hydrochloric acid combine with anion B with calcium cation here. Okay, so we have Ca at the first, Ca plus 2, calcium plus 2 at the first. Okay, and the other one that will be poorly soluble in water, that will be poorly soluble in water. Okay, so we have Ca at the first, Ca plus 2 that combine or bonding by the effect of diluted hydrochloric acid make it one, well, poorly soluble in water, and the other soluble. The first one combining it will be soluble in water, and the other one will be not soluble in water. Okay, so if we discussing the answer, we have bicarbonate and sulfite, bicarbonate and carbonate, carbonate and nitrate, thiosulfate and nitrite. Okay, we discussed before in the previous question that we have here that we have carbonate and bicarbonate. What is the effect of each one? The carbonate and bicarbonate salt release the same gas, carbon dioxide gas, by the effect of hydrochloric acid. So the same gas evolved by the effect of diluted hydrochloric acid. One of them dissolves and the other will not dissolve. So it will giving the bicarbonate dissolves with the effect of short time, and carbonate will not dissolve, forming percepted. Okay, we discussing this for the second time. It will give comparison between two important radicals, carbonate and bicarbonate anions. Okay, so we are going to question, or the right answer here will be question B, and we are going to question 12. We have question 12 says that the salts that not affected by diluted acid, hydrochloric acid, as we discussed before. Okay, we said if we discuss that we want to not make the effect, we want a salt that coming from strong anion. Okay, we have magnesium bicarbonate, as we said, bicarbonate affected by the effect of hydrochloric acid and will make dissolves. Okay, we have potassium nitrate. Do you think that maybe, okay, when we comparing, we must have the salt coming from strong acid? Okay, we have potassium nitrate. Do you think that nitrate or the salt coming from nitric acid will giving strong salt that not dissolved by the effect of one, which is diluted hydrochloric acid? Okay, we will continue our choices. Sodium nitrite in ANO2. Okay, so it will be what? It will be less stable than the potassium nitrate, as it will be removed by the effect of or affected by hydrochloric acid. We have the last one here, sodium sulfite, and also it will affected by the diluted hydrochloric acid. that will remove it from its salt, that giving the what the smell of spoiled egg. Okay, we have here the choices: hydrochloric acid, diluted hydrochloric acid, not affected on the strong salt, will not affect on it, will giving no reaction when the its effect on one, that it will be here less active than the salt that we have. So the hydrochloric acid less stable than nitric acid, as we discussing the stability or the weak and strong acid. So it can expel what? Expel potassium nitrate from its salt. So potassium nitrate will be the right answer, or any salt coming from the nitrate group NO3 negative. Okay, it's very important question here. As we said, we take it from the primary, third primary that we have, or third prep, sorry, third prep, that we have the strong acid here, nitric acid, and we take with the effect of heat on sodium nitrate. By a long heating of sodium nitrate, it will remove only one oxygen atom, on one oxygen atom, and by the effect of heat, change from sodium nitrate to sodium nitrite, and oxygen gas evolving. Okay, so it will be a strong salt here, as it contain radical very hard, nitrate anion, not affected by any acid that less than it, also not affected by the effect of heat with a very hard, that changes it sodium nitrate into sodium nitrite, change from white into pale white in color, sodium nitrite. So it will be here that we have the sodium nitrite will be less stable than sodium nitrate. Okay, we can't use diluted hydrochloric acid to remove the nitrate anion. Okay, it's a very important question. Let's go into question 13. Question 13 says that it can be distinguished between what? We have two different salts here with the same sample of pure water. Okay, so we discussing what? We discussing one soluble and the other will be not soluble. If we have the salt, it will, one of them, we have two salts. When adding water to each of them, one soluble and the other not soluble in water. Okay, let's discuss our choices. We have sodium carbonate and potassium bicarbonate. Okay, also here that we have one stronger, both of them may be what? May be solve in water. All of both of them will dissolve in water here. Okay, as we have the sodium carbonate and as a strong, easily ionized, and the potassium bicarbonate here also easily ionized, and both are what? Both are soluble in water. Okay, the second one we have sodium chloride and potassium carbonate. Sodium chloride, NaCl, salt. Okay, salt will dissolve in water, that we have the table salt dissolve in water, and also potassium carbonate, all carbonate dissolves in water, so it will be not distinguished or differentiated by using pure water. We have C, sodium bicarbonate and potassium carbonate. Okay, the difference between A and C, here we have sodium bicarbonate, sodium coming from a strong what? From a strong base, but carbonate coming from bicarbonate coming from weak acid, so it will be soluble in water. Okay, this is the first one. But here we have potassium carbonate, we have potassium carbonate. Okay, we have the other one, or calcium carbonate, it will be here calcium carbonate, it will be what? It will be soluble. It will be poorly soluble in water. Okay, it will be poorly soluble in water. Okay, we have our question: sodium bicarbonate and calcium carbonate. Sodium bicarbonate and calcium carbonate, they are soluble in what? Which one will be soluble? We have sodium bicarbonate, as we said, that one coming from weak acid here, bicarbonate, and the other one that we have what? We have calcium carbonate. Calcium carbonate not dissolving in water, as strong radical that we have calcium will not dissolve in water, or calcium salts that will not dissolve in water, or poorly soluble in water. So here we have the right answer, that will be letter C. And the last one here, we have sodium sulfide. I think it's easy soluble, and sodium sulfide also soluble. We can't distinguish between each one using the water, so the right answer here will be sodium bicarbonate and calcium carbonate. Sodium bicarbonate and calcium carbonate, it will be the right answer here for this question, with the letter C is the answer. Okay, let's go into question 14. Question 14 says that by analyzing the salt descriptively or qualitatively, 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 it's possible too. Okay, if we make a quantitative analysis, qualitative, qualitative means that we identify the type of element, and also that we know the percentage of each element in the what? In the compound that we have. But the quantitative, we measure the concentration and or the proportions of the salt component. Okay, we have our choices. It's possible to identify the proportion of salt component and determine the concentration of each component of the salt, identify the component of salt, and the last one here, recognize the number of atoms of the salt. So we will make a descriptive or qualitative analysis to identify the type of element here, or the component of the element that makes the salt, and not to know the percentage or concentration or the number of atoms that we have. So the right answer here will be letter C in our question. The right answer will be letter C. Okay, let's go into question 15. Question 15 says that to confirm for the presence of the hydroxyl OH group in the methanol, it sample CH3OH. What will kind of analysis that will happen to it? As we said, that we want to know the presence of the hydroxyl group, it will be present or not. Okay, that will, we want to identify the functional group here in the methanol or methyl alcohol. Okay, as we said, we make a qualitative or descriptive or the type or the kind of analysis, that knowing the functional group of the compound, especially in the organic compound that we have. Okay, so the descriptive or qualitative analysis aims to identify the functional or active groups in the organic compound. It's one of the very important question that we will take organic in that chapter 5. So we have descriptive, qualitative, and typical to know the kind of functional group. So all of the previous will be the right answer, and it's very important also question. Let's going to, depending on the meaning of the word qualitative analysis. Okay, let's go into question 16. Question 16 says that also it depends on accumulative knowledge here, that we have the least stable acids are, what are the property of the least stable acid? We have difficult to decompose and volatile, have we difficult to decompose and volatile, and they have high boiling point. What about them? Do you think that? No, it will be here high stable. The second one, easy to compose and volatile. Yes, decompose easily when we use it, and have low boiling point. So we can use it easily in the reactions. Yes, I think it's right answer. We have also choices easy to compose and volatile. Yes, it may be, but here the other one we have high boiling point, so it will giving wrong answer. They expel HCl from their salt. No, if it remove hydrochloric acid from its salt, that will be strong, not least stable. If it remove the hydrogen or hydrogen chloride, hydrochloric acid from its salts, so it will be the right answer here will be letter B, decompose and volatile easily and have low boiling point, so it will be the least stable acid that we have. Okay, let's going to question 17. Question 17 says that water has the ability to dissolve all of the following salt except. Okay, we said that we have a kind of water, salt, that can't dissolve in water. We have the salt, poorly soluble in water, that they are stable. Okay, we have the magnesium carbonate. Okay, all carbonate salt dissolves in water. Potassium nitrite, we said that nitrite anion, that it will be also dissolve easily in water. Potassium, so we have letter B here, we have silver sulfide here, that letter B, silver sulfide maybe, and the last one here, sodium sulfide. Okay, if we discussing it, the one that not affect or have the ability to dissolve in water, the strongest one, we have the coming from the sulfate anion, SO4 negative 2. We have here silver sulfite. Okay, so the salt poorly soluble in water, that will be silver sulfide. So the right answer will be letter B. Okay, let's go into question 18. Question 18 says that the reagent whose solution gave percepted with solutions, we have carbonates, sulfide, sulfite is. Okay, as we said, it will be stronger than carbonate, sulfide, and sulfite. It's also a repeated question. We have here carbonate, magnesium carbonate, silver nitrate, brown iodine solution, and diluted HCl acid. Okay, if we discussing that, we have also reagent get percepted with them. Okay, it will be percepted may make it stronger than all of the three. So we have carbonate, not a stable or not a stronger salt. We have silver nitrate. We said for the, I think it's third time that we discussing question belong to nitrate anion, NO3 negative, that we have silver nitrate, that we have brown iodine solution, it will be not making a percepted. Also we have diluted HCl stronger than them and will dissolve each one, dissolves each one. So we have silver carbonate, silver nitrate, silver sulfide, and silver sulfide will be poorly soluble in water, but the strongest one that will give percepted with carbonate, sulfide, and sulfide will be stronger than them, stronger than them. So it will be strong silver nitrate here, giving percepted with silver carbonate, silver sulfide, and silver sulfide, as they are all of them are poorly soluble in water, but here that we have silver nitrate will give percepted with the solution of them. Okay, so the reagent used to give percepted with all of these stronger reagent, we have silver nitrate reagent. Okay, let's going to question 19. Question 19 says that it's possible for a 9x in the following reaction according to the reaction, except we have reaction that a 9 of x all of the following that can dissolve. We have here, we have what? We have ax2, a2x aqueous plus AgNO3 silver nitrate aqueous, that giving ANO3, and at the end of that we have solid as percepted, we have Ag2x as a percepted. Okay, what will be the anion here that we have? We have carbonate, bicarbonate, sulfite, and sulfide. Okay, if we're discussing this one, the salt that appear in the form of percepted or solid, that will be weak anion, that will be weak anion. So we have X must be weak, that from our choices: carbonate, bicarbonate, sulfite, and sulfide. Okay, from all of these we have carbonate, CO3 -2, and here we have X here, that will be with radical, what? With radical divalent. We have A2X, that divalent giving to the cation A. So we have carbonate, bicarbonate, okay, sulfide and sulfide. So we have here sulfide also as -2, and sulfide SO4 -2, sulfide S -2. Okay, so the only one here that not, it's clear that through percepted of anion here, that formed that the anion carries electric charge, all of these carry -2 or divalent anion, and all choices here that carry -2. So the anion will be one of these choices, except what? Okay, except it means that one not have -2 as a radical for it, and it will be what? It will be bicarbonate anion that carry -1 charge. Its sample, it will be its HCO3 -1. So here we have the anion that not making the reaction, and according to the equation that we have here, the salt that giving divalent, it may be carbonate or sulfide, that not, the exception that we have will be bicarbonate, as it is monovalent with the one charge that carrying in it, so it can't be produced from this reaction. Okay, we have question 20 and the last of our choices today. Question 20, it's the last question of our booklet. We have oxidation of what group? We have by the effect of acidified potassium permanganate solution to the group what? Okay, the oxidation here, we said the acidified potassium permanganate will be affected with the one that we have. The one that we have will be, according to the reaction, we have sodium nitrite. Okay, we have sodium nitrite that will be less stable here. According to choices, we have carbonate and bicarbonate, one stronger, and this will be less stable. We have sulfite and thiosulfate, the same. Thiosulfate and nitrate, the same, but according to the equation, the effect of acidified potassium permanganate will be oxidized, that removing with the effect of what? Of the nitrite group by the effect of acidified potassium permanganate here NaNO2 plus KMnO4 plus sulfuric acid H2SO4, that will giving what? That will oxidize or make oxidation. Oxidation or oxidized means that it will increase the number of oxygen atom in the product. So we have oxidation here that will change from nitrite into nitrate. The oxidation here of group NaNO2 or nitrite will changes to nitrate NO3 plus potassium sulfate K2SO4 and manganese sulfate MnSO4 and water at the end of the reaction. It's very important reaction and also repeated question that we have, so the right answer will be letter C. So we can make sure that we have acidified potassium permanganate. Its color will be disappear when adding nitrite and it changes into nitrate anion. So it will be depending on the oxidation of the salt here, sodium nitrite, it changes into sodium nitrate. It is the last question of our booklet 13 today. Okay, thanks for joining. I hope you enjoy all our question. It's very important and we have different ideas for solving. If you have any questions, you can make a communication for it on every way of communication. We have الأستاذ book all or on الأستاذ book page on the face that we have different questions and we will discuss each question with the answer and write in the slides that we have all these questions that we have in our groups. Okay, thanks for joining, waiting for solving more question. Thank you. Dr. Shireen with you. Thank you and goodbye.